Welcome to the chemistry universe. Welcome to the wonderful world of NCERT discussion. And in this episode, we are talking about states of matter. Essentially, we're talking about gases, but yes, it is titled as Unit 5 of NCERT 11th, which is states of matter. This is Shishir Mittal from Vyas Certification. Be with us. Now, the question says, what will be the minimum pressure required to compress 500 decimeter cube of air at 1 bar to 200 decimeter cube at 30 degrees Celsius? Now, what is to be done? What is the standard way of solving such problems? You know, the best and the most beautiful way is when you are reading a problem, note down the data which is given. So first write down given. What is given? What will be the minimum pressure required? This is asked to compress, okay. Now what we have V initial as 500 decimeter cube, and I hope you recall 1 decimeter cube is equal to 1 liter. So this is essentially 500 liters of gas of air. This is air at pressure is 1 bar and temperature is 30 degrees Celsius. And I hope you remember that when we are using any chemistry equation, degrees Celsius is absolutely useless. So we would need to convert that to Kelvin. But again, I'm just noting down what is given. Initial pressure, temperature, and volume is given. Now, at 300 degrees Celsius, what is this? This looks like temperature. There are two meanings which could be attached. They have not given it as constant. To this much or to this much at 30. There are two meanings. The way the grammar has been framed, it's not very great because initially, I'm very clear, initially it is 500 decimeter cube. Initially it is at 1 bar, fine. And final volume is 200 decimeter cube, that also is final. The meaning of temperature could be that final temperature is 30 degrees Celsius. That is one possibility. And it might also mean that all this drama is happening at 30 degrees Celsius. It is a double meaning question. Not good. But I mean, that is the way NCERT is. Now, if I just assume that final temperature is 30 and initial is unknown, unfortunately, this problem cannot be solved. Okay. So we have to just become shameless and assume that temperature is constant at 30 degrees Celsius. Okay, fine. And what is this concept of minimum pressure? So whenever you note this data, now you have to imagine a few things. Just imagine that initially the gas is enclosed in a cylinder, right? And then what do? You try to compress this gas. Now, when you compress this gas, when you apply pressure, the piston is pushed down. And say now the piston moves down to this location. So, it means that you have to apply a certain pressure. Now, initially, pressure is 1 bar. I have been given that initially pressure is 1 bar. So, when you are compressing, it is very obvious that if you are pressing something, the outer pressure has to be more. So that means P external should be more than 1 bar, right? Then only you are compressing it. Fine. How much more? 1 bar, I mean, is it 10 bar, 100 bar, 1000 bar, million, trillion, quadrillion bar? It could be, I mean, if you use the pressure of entire universe, well, you can flatten it, no doubt. So there is no limit to maximum pressure you can apply. But they are asking you minimum pressure. Maximum, there is no limit. That is why it is pointless. But there is some minimum pressure you might need to apply. Why? Because as you apply some pressure and the gas gets compressed, the pressure of gas inside is also going to increase. So, say for example, this volume becomes half. Temperature is constant. If the volume becomes half, pressure would become double. Initially it was 1 bar. Now if the volume is half, the pressure would become 2 bar. And you are still trying to compress it. Because half of 500 is 250 and I'm supposed to still compress it till it comes to 200 decimeter cube, right? So do you see that the pressure outside also, if it is just more than 1 bar, that is not sufficient. It has to be at least so large that finally, till final volume of 200 decimeter cube, there is some final pressure, right? And you should be able to compress it till that pressure. Agree? You should be able to compress it till that final pressure. That means P external finally should be at least a little more than P final inside. Inside, whatever is pressure, you are compressing it. So outside pressure has to be more. Minimum, it has to be equal, but it can't be less. Otherwise, the piston will move up and it will start expanding instead of contracting, right? Fine. So what I understand by this minimum pressure is that this minimum pressure is nothing but at least the final pressure which is going to be there. And once we are clear with this idea, temperature is constant, so we apply Boyle's law. We have to find P minimum, or this is external. This is what is given and asked, but we have discussed and we have understood also a little part of what we need to do, and now we will execute that idea. How shall we do it? We will say at constant temperature, P1 V1 is equal to P2 V2. We apply Boyle's law. So P final is equal to V final, P initial, V initial. Now what was initial pressure? 1 bar. Initial volume is 500 decimeter cube. Final volume is 200 decimeter cube. This is P final, which if you cancel, it comes out to be 2.5 bar. So finally the pressure inside the vessel would be 2.5 bar. That means from outside also you must apply at least 2.5 bar so that you are able to push it till the internal pressure also increases to 2.5 bar. 2.5 bar, my dear, is the final answer.